We're going to talk about troubleshooting whether or not there's a bad electric motor. This happens to be a IDM machine. It doesn't matter really what machine it is. If it's got an electric motor, the procedures are the same. Customer complaint here was that the motor is making a growling sound and kicking the breaker. We wanted to verify whether or not it truly is a bad motor. In this case, we needed to first make the decision whether or not it's a single phase or three phase. Typically, single phase motors are going to have capacitors, capacitor covers. This one does not have any capacitors. However, the manufacturer has put the capacitors inside the cover. So we got to make sure. The way we can verify that is we can look at the ID tag, and the ID tag will tell us whether or not it's a single phase. We proof that out and we verify that we do have capacitors. Now, if you've got a bad start capacitor, capacitor holds an electrical charge, kind of helps get the motor started up to speed. It stores an electric charge. We can check to make sure the capacitors are good first. In this case, what we do is we shut the breaker off to the machine. The breaker, we follow the electrical conduit along the wall, and we find the breaker, and we make sure after we shut the breaker off, then we verify at the top of the contactor whether or not there's power. That's very important. As long as we don't have power, then we can go ahead and come down to the capacitors. These capacitors right here, there's the start capacitor and the run capacitor are right next to each other. They're easy to check. We remove the female spade connectors from one at a time. We take a screwdriver and we drag the screwdriver across from one terminal to the other, grounding it out, making sure that we have that the screwdriver touches both terminals on the left and the right. That way it releases the electrical charge. If you don't do that, you could get electrocuted and you could die. So you want to discharge the capacitor, and then you use a capacitor checker. There's some that are available commercially. We use a electrical meter that has a capability to read the microfarad rating, and we compare the reading on our capacitor checker with the reading on the capacitor itself. This unit has two capacitors. We did the same procedure on both of them. We did them one at a time independently, removing the wires, discharging the electrical current and the circuit that's inside, tested the bottom one, reattached the wires, come up to the top one, disconnect those wires, discharge the capacitor, check the reading on the microfarad. Compare that with what is on the outside of the jacket right there. It'll give you a reading of where the allowable limits are for microfarad. Both of these passed just fine, so we know we don't have a capacitor. In a lot of cases, it's just the start capacitor that we can just replace, and then we're good to go. By and large, that's going to be the problem for a hard start on an electric motor. In this case, the capacitors were fine. So what we did was we went ahead and we found the wires that feed power to the motor, which happens to come off of the overload protector. We disconnected these two wires off of the bottom. In this case, they're on T1 and T3. We brought them up to the very top of the contactor where our incoming power supply is at, and we attached them to L1 and L2. Then what that allows us to do is go back to the circuit breaker. We go back to the circuit breaker, we establish power, and what we've done in that case is we've actually bypassed the contactor and the overload protector as a possible source of a problem. If the contactors inside are burned, that could create a voltage and amperage issue that is going to be noticeable in the motor as a symptom. In this case, after we took the wires that fed the motor, put them at the very top of the contactor, we established power from the circuit breaker, 40 amp circuit breaker, and it kicked the breaker after about 3 seconds. According to our nameplate tag right here, it should have been 25.5 amps maximum under full load, and we kicked the 40 amp breaker. Just to verify that our system is not under any load, you see that we removed the pump belts off of the motor, and we turned the pump over just to make sure that we don't have any lag, and the pump turns very nicely without belts on there. Obviously the motor is able and free to start on its own. So that's the procedure for eliminating any possibility for an electrical motor overload. It could be a seized up pump. It could be a regulator that's bad. We've isolated that by taking the belts off. Then we come over here and we check the capacitors and make sure that's not something simple. Then we bypass our contactor and overload protector, which is another possibility. In this case, it definitely is appearing that it's a motor problem. Now we need to find out why the motor went bad. Very possibly it could be that this unit right here is actually built for 230 volt power. While we were checking our voltage at the top of the contactor, we found that they have 210 volt line voltage, which is only going to go down once it's under load. Typically under load we'll see a 210 volt line drop down to 208, 205. That means that this unit should have been a 208 volt motor, and it's a 230 volt motor trying to run on 208, causing premature failure. So we have to have a conversation with the customer now to see if they want to replace it with an OEM motor at 230 volt and take their chances, or if they want to convert the system over to 208, which is what it should have been to begin with. If you have any questions, you can give us a call at A&E Industrial Equipment. Website's aefresno.com, or talk to your supervisor for any other explanation, or watch this video again, because I know we went through rather quickly. Try to keep this around 5 minutes or so. It's a lot of ground to cover, but look at it again so that you're familiar. Stay safe, and safety is the number one thing.